I'm Wally from Black Dot Energy, and this is the technical training maintenance videos on WITS Junction campus, and this video is specifically on the solar component. There's been quite a number of videos that we've done, but more marketing videos on the whole junction setup and what makes this entire system so unique, the combined hybrid with solar and cogeneration and the district heating. With this video, we're going to show you the main points that you can identify if there's a problem with the solar system, so that you can contact the necessary installer or contractors to in fact come and fix whatever needs to be fixed. So first of all, and the main key section is there electrical power to the system? The way that you'll identify that is our controller, the Technique Alternative controller at the back, should always have a display. If there's no power or no display on that controller, there is in fact an electrical isolator switch at the back. Check that that is switched on, and also the trip switch at the top. This campus, as I've mentioned in previous videos, does have a full backup diesel generator setup, so there should never be a point where there's no electricity. So even if the ESCOM supply is down and you can hear the generators running, but there's no power here, it means that somewhere the power has stripped and there's no power to the solar plant. If you can in fact see that there's a display, the next item to check is there circulation? Here is our two pipes coming in and out of the solar plant. So this again, exactly the same setup as we have at David Webster and Bernardo Hall. It's just a different size setup. We have our plate heat exchanger at the back, and it's an indirect system. So the liquid that goes up to the solar plant and the liquid in the tanks don't mix. It's an indirect system, so we've got a glycol loop on the solar side and we've got fresh water on the tank side. And the way that we transfer that energy is through the plate heat exchanger. On both sides we've got circulation pumps, and you can see the circulation pumps there at the bottom, the green very high quality Velo, and that circulates the liquids on both sides of the heat exchanger, transferring that energy. So if we have the liquid or the temperature that goes up to the roof to the solar panels, it's now nighttime, so this is at merely 15 degrees, and the temperature that's coming back, it's now 25, but that's really heat that is still remained in the system. But this is visually how you'd be able to identify whether the system is in fact circulating. If there's a temperature differential between the temperature going to the roof and the temperature returning from the solar collectors, showing that there is heat coming from the roof. If that shows that there's in fact no temperature differential, there's only a few things that could be wrong. Number one is that at some point the system has gone into overpressure, and again, similar to our other plants, if the system goes into stagnation, we've got our solar expansion tanks, the membrane expansion vessels. Again, these vessels have got a rubber membrane in there, half liquid, half air. If the system goes into stagnation, in other words, over temperature, so it's producing energy, but there's no consumption, the system goes into stagnation, it pushes this first tank, which is filled with cold water, it then expands this volume into these expansion tanks. And again, they're sized so that the entire liquid volume that's in the solar collectors on the roof can be expanded into these tanks. And hence, that's the way we protect the system. If anything goes wrong with this expansion protection, there's a backup safety, and that's the safety overpressure valve. If this opens up, it will release the glycol into these drums to in fact protect the system as a safety failure. If that opens up, it will release the glycol. When that glycol is released, it means that the system doesn't have the hydraulic capacity to in fact circulate. Then there will be no temperature differential here. And by merely looking into the drum, and you can identify that the glycol has been expanded into those tanks or released into the tanks, you can contact the contractor and notify them that the system has in fact gone into a safety pressure release. The glycol is released into the drums. The contractor needs to come back on site, replace the valve because it's only intended to really open once, and then reload the system with that glycol. Again, similar to the other plants, the reason for the drum is visually that you can identify that the system has released glycol, and secondly also that we can use that same glycol again to repressurize the system and to load the glycol. The other way that you can see that the system has released glycol is at the back here. We've got a pressure gauge. So the system runs at a 3-bar pressure. If at any point, and maybe not even if it's released glycol into the drums, maybe there is a fitting on the top of the roof that has gone loose and it's leaked out glycol, you'll be able to identify it by looking at the pressure gauge. So if the pressure gauge does not show 3-bar, maybe it shows 1 bar, we know that somewhere a pipe joint has failed, the glycol is leaked out, and the system doesn't have the necessary pressure to circulate. Again, you then notify the contractor, but you can identify the problem by saying there's no pressure in the solar loop, or it has released glycol into the drums. Please come inspect, but the solar system is not functional. We are currently in the process of doing an upgraded module on the Technique Alternative controller so that we can remotely monitor the system to in fact see exactly how much energy is being loaded into this plant room. Is it optimal? And also to identify at any point if there is a problem. This concludes our solar video. Thank you for watching. Please also see our other solar videos on David Webster and Bernard Hall, and also the other technical videos on this plant. Again, the intent is that we can always ensure service delivery for our students and that there's hot water at any given point. Thank you for watching.